As a recap, I think we're primarily looking at primarily the high availability side of the story in Azure, what options we have and what products we have. So there is quite a set of tools available in Azure for high availability. I think apart from the basic uh, where the SLAs are provided, like the high availability story in terms of availability zones and also multiple regions across regions and all those things that we saw. But apart from that, there are also few tools which are available under the networking category as well, so which will address the high availability concerns. So in that category, I think we I think in the last sessions we saw few of them, which is starting from just recap the load balancers we saw. So the last session we saw the public and public load balancer, internal load balancer, and yeah, they they route the traffic to all the VMs, and generally these VMs do not have a public IP, but this load balancer will have a public IP, and that will route the traffic um, to other VMs behind the scenes. So that is the public load balancer, and it is also possible to have an internal load balancer as well. So we saw about that, and also we looked at why you need to use load balancers and what are the various options we have, standard versus basic, uh, and we also looked at the standard is pretty much kind of advanced, but basic is simple. Standard covers 1,000 instances, and it is having advantage like multi availability zone support and multi-dimensional metrics feature high availability port. Uh, SLA is 99.99%, but here we don't have any SLA there, and also it covers HTTPS additionally as well. So these are the features that we saw for the load balancer, and also we looked at the terminologies which are used, the probably the front-end IPs, back-end pools, health probes. The front-end IPs will give you the load balancer will have two sides. One is the front-end IP, which will have the public IP, uh, and the back-end pool where we'll have a group of VMs associated to that so the load balancers, and health probes primarily to monitor the health of the VM. So that let's say there are three VMs are there, the load balancer should continuously monitor via health probe the VMs and see whether any VM is not performing well, or it is switched off, or any VM is having high CPU or high resources. So yeah, it has to continuously monitor the health, and this is the one which decides the traffic where to go, so which VM to send. So it is important to know the health of the VMs for it, and also we can configure the load balancing rules. Uh, uh, yeah, and also it can also give inbound NAT rules and outbound rules also in terms of how the traffic should go. Yeah. So these are the features of load balancer. But the load balancer, there are other products also are there in this load balancer category. So we also saw based on, I mean, this table is important. If you remember, we're covering four products, more or less all coming under the load balancing category. The Azure front door, and whatever we saw, the load balancer is all at a regional level covering the non-HTTPS traffic. Uh, but if you want to go again at the same regional level, then we also have application gateway, which is covering the HTTPS traffic, the web traffic. But if but the restriction of these two are regional, which means it can't go beyond availability zones. The scope is restricted to availability zones max, availability set and availability zones. But if you're talking about VMs across regions, which is like a global kind of a requirement, there are equivalent products in Azure. Again, the same category of non-HTTPS and HTTPS is HTTPS. So for non-HTTPS, which is Traffic Manager, and for HTTPS, it is Azure Front Door. So these are the four products that we have in this scope. So I think in the last session, we were looking at a demo of this load balancer. I think unfortunately the demo didn't go well. So what I did is I think the mistake which I did in the last demo was that the VMs that were configured were in different regions. So that was the issue. Meaning the US East, the other VM was not in US East, so I took randomly some other VM, but the other VM which is participating in this load balancer was in a different region. That's the reason we couldn't see that VM when I select the load balancer, when I create the load balancer. So today what I did is just to speed up on the time. So let's start with the demo of this load balancer. And let's understand how the load balancer is routing the traffic. Basically, what I'm doing here is okay. Before
Uh,
going to that internally,
Shyam,
yeah,
Shyam Bala here.
yes,
Before
Bal.
we go, can you go to that table again? You said that load balancer is a non-HTTPS, right? So we can hit that HTTP, I mean that URL from not from the front door, right? I can directly access the load balancer directly also, right? The URL.
Yeah, yeah. I mean, you can. I didn't get a question. I mean, the URL you can access it from browser. Is that what you're asking?
Yeah, yeah, we can directly hit, right? In that case, is it secure to have non-HTTPS? Is recommended is HTTPS, right?
Yeah, I mean, it depends. I mean, it for always it is good to have a HTTPS based traffic. Uh, but for example, let's say if you're using internal or it is not it's not sharing any personalized information, then it is you can also use HTTP. I mean, if you think if it is secured and it has to be if it, for example your application is not secured and it is not having any personal identifiable information, and also you can still use HTTP
Yeah,
for
yeah,
such
that is correct.
requirements, right? So
Okay, correct, correct.
yeah, if you're looking for encryption and HTTPS, I mean security, if you is first for your requirement, then HTTPS based implementation is always advantage. I mean, it's more suggestible and recommended. But your application is not highly critical or not. It is internal purpose and not very I mean, not very like personal information is not stored and all those things. Then yeah, it's okay to go with HTTP also. I mean, even in real time, if you see, most of the applications that we use are HTTP only, not HTTPS. I mean, only if the banking sites or any other financial trading sites, and those will be definitely HTTPS. Yeah. So, but these will not be HTTP. I mean, normally it is HTTP. Yeah.
Yeah, yeah. Okay, okay,
Yeah.
fine. I just had a doubt if somebody hits directly,
Yeah.
it's not secure.
I mean,
Okay.
from end user point of view, I mean, the which one we use, like out of these four, I mean, for end user, it there's no difference for him. For him, it is just a browser URL, and he will hit it. At the max, he will know whether HTTP or HTTPS. That is the only difference from end user point of view. But as an architect for in cloud or in Azure, um, when it comes to uh, you have four options with you. So which one you select, that is based on well, first of all, we need to know. We should have two answers. One is it are we talking about HTTP or non-HTTP based traffic? So that is first thing, and also where are the VMs located? Are they regional within, like, are they restricted to availability zones, or are we talking about a global where the VMs is in different region altogether? Two VMs or one VM is in one region, other VM is completely different region. So these two will answer where which one to choose. Um, yeah, so so that is one differentiation that we need to know, and also these two are inside a VNet generally, but these two are outside VNet, meaning across
Okay,
VNets.
okay.
So it is something global, right? So it can't be
Yeah,
within
okay.
a VNet. It will be outside a VNet. Uh, Yeah,
Okay,
so
okay,
these are
got
three
it.
things that we need to keep in mind. Yeah.
Okay.
Okay. So yeah. So with this, I today before this call, I just quickly created a few VMs just to save some time. Because creating the VM and like I mean basically what I was trying to do for this demo is uh, maybe I didn't create a third VM, but I just created two VMs. So I am trying to create a load balancer, and what I'm planning to do is I will create VMs like two VMs. Both of them are Windows 2019 servers, Windows Server 2019, and both of them were in the same availability set. Um, so I ensured that both these VMs are in same availability set, and I associated just like any other VM creation, I created these two VMs, and after that I connected to these VMs and installed IAS server. Uh, IAS server is like a web server, um, so that I could access on port 80. Port 80 is like default port for web. So I could access IAS server, the default screen that you get in IAS. And now I linked these two VMs to a load balancer. Uh, so now when you hit it, uh, now the load balancer will have public IP, but these two will not have a public IP. So basically, these two will have only the private IPs. But the load balancer, I create a load balancer and I linked these two VMs to the load balancer, and I associated a public IP as well to this load balancer. So that way, when as a user, when I try to hit um, the URL, the load balancer will forward the traffic to one of these VMs at any given time. So it will keep on monitoring the health probe and check which VM is active and which VM is good to transfer this load, and accordingly the traffic will be routed to one of these two VMs. So that is what I want to show the demo today. So for this, what I did is as a prerequisite. This is I'll go to the Azure first. Okay, here. So I created two VMs here. This is VM1. If you look at this is on East US, and this is having a public IP 182.155, and also the second VM, which is also having this. Yeah, this VM2 is also in East US too. Uh, so and now when I try to hit these two VMs, uh, this is the I installed IAS server, Internet Information Services, Windows IAS server. So that way I could access these two on a public, uh, these two I could access it. So I mean, this was before the screenshot. So now I removed the public IP. So that's why the screen is gone. But actually it was just before associate. I quickly created a VM and quickly assigned a public IP, and I checked. So these two were having VM1 and VM2. So basically we have two VMs now. So I just added VM1 and VM2 just to show you where to which server the traffic is going to. So that's the reason I added these two. Um, and now let's go to the load balancer screen. So yeah, this is normal VM. It's nothing complex. It is just a VM1, VM2 creation. And the third tab, which is this is where I created a load balancer. If I go to the load balancer, uh, create load balancer. Yeah. So this is where you create a load balancer, and here by default the public IP will be associated to a load balancer, and the load balancer has backend pools. This is where you associate link the VMs. So here I linked these two VMs. So that is what this link is primarily. This link for a load balancer, I'm linking both these VMs. So this is where I create this in a backend pool. under backend pool, I will link these two VMs. So, and also this is what I was referring as health probes, where you need to create a health probe where you are telling the load balancer to listen on port 80 because IAS will be running on port 80 by default on this VM. So I'm asking to listen on port 80 and the interval like every 5 minutes of interval. I'm asking to 5 seconds of interval. I'm asking to check what is the health and also if there are you can declare that as unhealthy after two consecutive failures. So this is what I was telling the health probe rule. Then the fourth item is load balancing rule. So what should be your rule to the balance the load? So this is what I was referring. The load balancer rule is I'm telling the the if at all the traffic comes on this public IP address, I will forward this traffic to port 80 of both of the virtual machines available under this backend pool, and also you also monitor the health probe. So this is the one which connects everything. So far the previous steps it is just creating a load balancer and then created a associated a backend pool. Um, but unless you create this rule, nothing will work. So this creating this load balancer rule is the final step that will connect everything. So so basically here where what I'm telling is any traffic that comes to this load balancer IP, route it to the VMs which are in this backend pool. Here it could be two VMs or it could be three VMs or it could be 100 VMs. So it is how you configure the backend pool. So at the max, as per the PPT, if you remember, there are 1000 for a standard. It is 1000 VMs is what you can link here. So 1000 VMs can be added in your backend pool to monitor to that extent. So yeah, here I created two VMs here. So and then I'm asking to monitor the health on port 80. Um, I mean here it is port 80, but in let's say on this VM you have some other application running on a different port, then you need to tell what port to monitor. So that is what is important here in the health probe. Whatever you ask to monitor, it will monitor. So by default, I'm asking to monitor on port 80 because my application is running on port 80. But let's say your application is running on a different port, you need to tell that what port it is. Right. I will come to session persistence later, but this session persistence requirement, yeah, I will show. I'll come back to this. So and then idle timeout is 4 minutes. So this is where we created the load balancer rule. So now all my stuff is all ready. So now what I will do is I will publish this as my IP address to the end users. I mean, the end user, of course, I can associate a domain name to this, but generally, we don't have the domain name created for this, but generally, let's assume we're giving this is the public IP to the users. So when I hit this, I'm hitting the IP of the load balancer here. Now the load balancer will either route the traffic to VM1 or VM2. So that is what my expectation is. This here now it is pushed to VM1, and if I refresh it, uh, probably maybe I will go to a different browser. This browser will try to cache this information, so that's why it will not change to. So I'm trying to hit multiple times, but it's always going to VM1. Probably it's a cache data. Let me go to a different browser, the incognito window. This one will not be cached. This again gone to VM1. It's not going to VM2. Okay, so see if it's gone to VM2 now. So the previous one has gone to VM1, and now this traffic from a different browser I tried, and this time the traffic is routed to the VM2's IIS server. So yeah, so that is a differentiation. So maybe you can multiple times you do, so the traffic will be multiple times you hit. It will decide how and when it should route the traffic. So accordingly, it will route the traffic to a different browser. Sometimes this might go to VM2 or one also, for example. But at least we got once. Let's see. Generally, these browsers will do a caching. So it will try to load the request to the same set. Let me see if I have Mozilla Firefox is there. Let me try hit from this different browser. Okay. So notice it's gone from VM2 to VM1. So yeah, so you get an idea, right? So basically, here we are talking about migrating this traffic using a load balancer. We are routing it to different uh, traffic in a different virtual machines. So the again, why it is coming to the high availability category? Let's say if this VM1 is down, for example, so the traffic will be it will identify that VM1 is down, and it will route the traffic to the other VMs which are active. So it will not send the traffic to VM1, for example, uh, unless the health probe is again back to positive. So it will not do that. So that is the advantage of this load balancer. So any questions here? Just to
Shyam, Mani here.
yeah,
Shyam, yeah.
yes.
So if I want to configure, like HTTPS, like a certificate-based security or something, so we do the same procedure, meaning we follow the same steps, right?
Yeah, yeah.
Meaning
It
instead of
is
port 80,
yeah for HTTPS the port is 443. So that is a
okay.
standard port for HTTPS traffic. For HTTP
Okay.
the port is 80. So yeah, so for the process is same though. So for HTTPS, additionally you might need to have certificates for HTTPS. So that will be an additional step. But apart from that, the process will remain the same. But
I see. Thank
uh, yeah, but this is primarily for non-HTTPS category. I mean, the load balancer here is if you're looking for HTTPS based traffic, you should use application gateway. I mean, for
Oh,
example,
okay.
this supports both HTTP and HTTP. It's pure web. This will be more suitable for HTTPS kind of a requirement. But this
So
is
that means we do have a service called application gateway. So where we configure is it? Is that right?
yeah,
Instead
yeah.
of
What
load
we saw now
balancer?
is a load balancer. Uh,
Okay.
this is not a suitable kind for HTTPS. So if you
Oh,
have a requirement for HTTPS, then you should use application gateway.
oh, okay.
Okay.
Thank you.
I mean, that is obvious. That's the reason you. I mean, the next session is that basically we'll be going to HTTPS next. So in that we will
Okay.
cover this concept. Yeah. So
Yeah, okay. Thank you.
yeah, you're right. So what is difference is that in HTTPS, yeah, you might need to have a certificate for a HTTPS traffic. So you need a. It's called uh, the new name is called TLS. So Transit Layer Security. So the old name is called SSL. So people call but still with old name as SSL, but they're referring TLS. So, but in this case, you need to have the certificates that are to be generated. Generally, the for HTTPS traffic, the certificate is like um, you have to trust the two entities. So you need to have a certificate, which then generally the server component, and there will be a client component. The server component should should have a certificate. The certificate could be created as part of your enterprise. The certificate can be created, um, which is called a self-signed certificate. If it is created on by you or your organization, but it is valid only for your internal applications because it is created by you. It is not globally recognized. So it is okay to use self-signed certificate if it is an internal application. But if you want the certificate to be used, let's say your application is a global application and will be used by many end customers, then you should have a proper uh, third-party approved uh, certificate, which means like there are a lot of third-party vendors who provide the certificate. Even like for example, Azure and any cloud vendor also provides. But you can also buy this with, like for example, vendors like DigiCert, uh, 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 or I don't remember other names, but there are a lot of vendors who provide this. So you can buy the certificate from them and use that certificate in your server. Uh, and also, core is the client, so they should also have the certificate. The public key should be there with them. So using public key, they will call your URL, and that's how basically you're trusting by creating the certificate. You are basically trusting the two and making trust between two entities, server and client. And as long as the client is calling the server with the proper credentials of the certificate, uh, then the traffic will be approved, and also the traffic will be approved is one area, but other than that, the traffic will be encrypted over the transit. So there are, yeah, I think, sorry, I'm going a bit deviated, but I think this is important concept to know. So there are two things in this when you're using HTTPS traffic. One is uh, certificate generation process, uh, and also this other one called encryption. Uh, so encryption, if you're using HTTPS, then you are using um, the encryption over transit. So which is more secure because over the network, before data are being transferred from server to client or client to server, everything in this process is encrypted over the network. So it is more secure compared to a non HTTPS based traffic. Yeah. So yeah, this step would be an additional step, like managing the SSL and or TLS certificates. Um, uh, if the TLS is, for example, client is calling without a proper certificate keys, then the traffic will be denied. So um, so yeah, anyway, we'll cover this in the when we go to the Azure the application gateway section.
Okay, thank you.
Yeah. Yeah. Any questions here further? Yeah. And one thing is that this load balancer uses this internal algorithm to route the traffic. So when it is routing the traffic to various, there are a lot of VMs here on the right hand side. When the traffic is coming to load balancer, so it internally uses an algorithm called 5 tuple hash algorithm. So which is primarily it looks at the source IP, source port, and also the destination IP and the destination port and the protocol. So if you combine all these things in an algorithm, always you get a unique value. So 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 basically, when a traffic is coming, it will apply this algorithm and it will decide what should be the destination that it should send. For example, we saw it is randomly sending to VM1 and randomly sending to VM2. Okay, that is okay because we have only two VMs. But if you have more 100 VMs, it should always be unique. More or less, it should be unique. Like it should not send the same traffic to the same server again and again. So it should be always unique. So uh, so to generate that uniqueness of sending the traffic always to always it should send to a new VM, not to the old or existing VM. It uses an algorithm like this. It's a combination of this IP port and protocol. So that way, always the traffic is routed to a new VM, not to an existing one. Okay, and yeah, and there's one more requirement which I was telling. I'll talk about it later. Um, in the load balancing rule, we yeah, this one. If you look at this, is something called session persistence. This is a special requirement where there will be requirements where the session that is available in the client. Uh, if let's say if you want to route the traffic to the same client again and again, there will be common requirements where just to avoid the browser hits like you want the data to be loaded very faster, and you don't mind even if the traffic is going again and again to the same server, but your requirement is to load the screen faster. So if such is your requirement, then you can and this will make use of cookies, the browser cookies. But the idea is that um, when you hit it, the first let's say the traffic is going to VM1. But if you enable this by saying client API or client API protocol, so by enabling this, it will not use this 5-tuple algorithm. So it will use only the source IP and port algorithm. This in fact use only the client IP as your algorithm, source IP only as algorithm. So which means the traffic will be always routed to the same VM again and again. Even if you hit multiple times, the traffic will be routed to the same VM again and again. So basically there are exceptions where if you are setting this session persistence, I think there was a question in the last session. Is this the default, or we have any? I think Ganesh was asking this question. Is this the default algorithm, or do you have any other alternatives? The alternatives are yes, this is like session persistence where you can use client IP only, then it will apply only the source IP, only source IP and port as your hash tuple. So that way the succeeding traffic, I'm talking about the first one, I'm talking about the second or third one. The succeeding traffic will always go to the same VM when where the first traffic went. So it will be always routed to the same. So the advantage in that way is that the traffic will be faster. It will not it will not try to identify, apply this all these rules and also identify which VM it is. It will not go through all this process. So the load will be faster. But the problem with that is that you are not relying on the advantage of having multiple VMs in your stack. So yeah, there are ifs and buts, but again, this is a design choice. Like whether you want to pull the data faster, or there could be requirements where they call us client session affinity. So uh, so your outcome of your website is more inclined to the user's location or user's IP address. If you have requirements like that, then you can always use this client session affinity or session persistence concept. Again, you can read this here. Session persistence specifies that the traffic from a client should be handled by the same virtual machine in the backend pool. Same virtual machine, not the different one. Um, so, uh, so by saying none, specifies that the successive request from the same client may be handled by any virtual machine. If you say none, then that's what was there before. So that's why traffic was going to VM1 and VM2 in our case. But if you say as client IP1, the first it goes to VM1, the second and third and fourth, fifth, everything will go to VM1 only. That is the difference. Yeah. So was this clear? Sorry, any questions here?
No, Shyam.
Okay. Right. So let's move on.
Okay.
No, carry on. Sorry.
Okay, right. Okay, so I think, yeah, we are done with the load balancer now. So we are moving to the traffic manager, which if we go back to this table again, uh, yes. So traffic manager is also uh, the same category, non-HTTPS like load balancer, but just that it is global. It is sitting outside, not inside a virtual network. That is one difference. Yeah, and also it is outside the VNet, and it supports multiple regions. So that is what we are looking at now. Traffic manager. So traffic manager. Yeah, I think we discussed also this along in the last session, but just to summarize, this is a DNS based traffic load balancer. So when in exam, if you see any question related to DNS, um, the answer, the DNS based traffic, then it is always traffic manager is your answer. So um, yep. So DNS based traffic manager is primarily the traffic it will distribute the traffic across the globe, which means we're talking about across regions. If you see here, this is a symbol of a traffic manager. So whenever a client is trying to send a request via some google.com, so it will first go to the traffic manager, and traffic manager will decide the traffic, and it will push the traffic to various regions, whether it is Europe or North America or different regions. So it will do to traffic. Uh, and if you look at the features in this, are primarily it increases the application availability, and also it will improve the performance of the application just because the traffic is routed. It has a lot of algorithms where you can configure. Generally, the default rule is it will load the traffic when you have the traffic coming. It will route the traffic based on the network latency, the lowest network latency. Sorry. So whichever is faster, it can load. It will try to go to that region and load the content from that VM rather than a VM which is far away from where this user is trying to request. So it will look at the geographical parameters as well in terms of the traffic, how much time it takes to reach and get the data. So it will always takes the lowest network route rather than the longest network route. So yeah, and also this will also help you to use a downtime. It will have the combine hybrid applications. So which means like this the sites that you want to link to a traffic manager. It this This is another difference where you can't do this feature in the previous load balancer. It supports multi-cloud, and it is all and also it can be hybrid, which means this application could be an on-premise application also sitting in a different location. So this is another important difference compared to the traffic manager versus the load balancer. So, but both are same. Both supports non-HTTPS traffic. But only the scope matters. The scope of traffic manager is global, and the scope of traffic manager is outside VNet, and the scope of traffic manager is it can take the sites from a multi-cloud. Can support multi-cloud. Can support hybrid also additionally. But because this is working because then it's all domain. Okay, so we're talking about DNS based traffic. The what it knows is the DNS could be uh, the DNS is like google.com or any other domain. So that could be sitting in the same cloud, or it could be different cloud, or it could be an on-premise anywhere. Only thing is it should have internet. That is only prerequisite, right? So yeah, 1 minute. Yep. So that is the only prerequisite for this traffic manager. And remember this, we also discussed about how this traffic manager generally flows across various domains. Let's assume we have uh, partners.contoso.com. So this is the domain name. And let's say you have three applications, one deployed in US region, one deployed in EU region, one deployed in Asia region. So, so internally, these are the three sites that we have. So when a traffic is coming to this, you want to route the traffic to all one of the three regions, and each have a unique IP address. US will have a US IP, and EU has a EU IP, and Asia has an Asia IP. Um, so how this works is, either when you hit a domain name, it will route the traffic. It will come to traffic manager. Traffic manager has to decide one out of these three uh, and route the traffic. Um, to decide one out of these three, that's where the it needs some inputs. So those inputs are, these are two inputs. It will apply the traffic routing method. So there are a lot of options in this traffic routing method. So you should tell what rule to be applied to route the traffic. So that input is required for traffic manager, and also it will look at the health aspect, like how we saw in the load balancer, the previous one. It will also look at the health probes, and it will also identify the health of these, and then make a call to route the traffic between out of these three one. So so that, I think we have discussed this diagrams in the last session. So generally the traffic starts with a browser, um, some URL. Uh, Once you hit a URL, the traffic will generally go to a DNS service. Uh, DNS service is not, I mean, it is something globally available, not related to Azure. It is like common DNS servers that are available globally. So every domain should be registered to this global DNS server. So and so every time you hit a URL from a browser, behind the scenes, it is the traffic is first will go to DNS service. So that's where all the popular vendors like Google, Facebook, Microsoft, everyone should register their servers here. So so that way, this guy will know when a given traffic coming, what is the IP address, internal IP address that it should route to. So in this case, we talk about Microsoft. So it is this Microsoft would definitely would have already published the traffic manager details to the DNS. It will be registered to the DNS service. So as and when you get a traffic is hit on a browser, DNS service will know that this is for traffic manager, and it will give the uh, IP address of this of traffic manager to the browser. And then after that, the successive calls will directly go to the respective module with which the traffic manager internally redirects the traffic to. So basically, the summary is that one thing we need to remember this thing is that browser will always knows IP address only, even though we are giving a domain name that is only for human readable advantage. But internally, browser needs IP address only, not the domain name. So someone should do the translation of the domain name to IP address. So that is what is done by this DNS service. So DNS service uh, will will associate the IP address. So further, DNS should know who are all the providers and what are their IP addresses and domain name mapping. And and in this case, let's say if a traffic manager site, then it will come to traffic manager, and traffic manager will has let's say he has three choices to make. Uh, One could be uh, for in this case like US, EU, and Asia. It has to pick one out of these three. So it will apply some pattern here and then select. Let's say selects US or EU, for example. Let's say selects a EU. So so it will send the IP address of this EU back, uh, and DNS servers will send that IP address of this EU back, and now the browser will not go to traffic manager going forward, to directly go to the EU, for example. So yeah, so I mean, yeah, these are something which are happening behind the scenes, which generally as a user we don't see this, but is all how this behind the scenes the browser will work, and a lot of DNS and the traffic manager equivalent components are all associated behind the scenes to route the traffic to a particular site. Sorry, any questions here? Is it clear or any questions?
Shyam, I just have a basic question. I don't know
Yeah.
whether it's right or wrong. So the difference, comparing the difference between Route 53 and Traffic Manager, right? So Traffic Manager, we says that it handles both Azure and non-Azure,
Yeah.
correct? That's what it is. Route 53 handles only AWS related.
Oh, no, no.
But
That is
saying that
also global. I mean, it is also multi-cloud.
that is also global.
Same like traffic manager.
But yeah, even in that case, see, when we are hitting the URL, right? The DNS will know that which IP address. Traffic manager will of Azure will hold only that what is coming to Azure, right? It's going to route to that particular load, and whatever that application is going to hit only the Microsoft Azure. Same thing with the AWS. Then why in that case they say that it handles both? It doesn't
Uh,
make anything.
I mean,
It is not going to. It's not going to, whether it is a Azure or non-Azure.
uh,
Is going to handle only the Azure route to the underlying servers. When it
no,
hits the DNS, it comes to this IP, right?
yeah. I mean, the advantage there is that this traffic manager has to pick one out of many, right? So the many could be an on-premise, or it could be a different cloud, or it could be within the same cloud. So, but but when it has to pick one out of many, um, the advantage in Traffic Manager is that it can intelligently apply some rules based on where this traffic is coming from. Uh, let's say your on-premise application is somewhere in India, okay, and the traffic is coming from US. So it will not redirect the traffic to data center in India. Instead, it will route the traffic to another resource which is closer to the US
Yeah,
location.
yeah, yes, yeah. I got that.
Yeah,
That handles that nearest shortest path it will take.
yeah.
But comparing between Azure and AWS, the
Uh-huh.
route it takes, right?
Mm,
So anyway, if we are hitting the traffic manager of Azure, is going to handle only those portion of it, right?
mm.
We don't normally configure this traffic manager of Azure point to AWS to route it.
No, no. I mean, it is not. It is a domain name, right? The domain name. Let's say if you're talking about using Traffic Manager, and let's say one of the web component is in. Let's say this is AWS component.
Mhm.
So something with AWS.com or AWS.windows.com, something like that. There will be some domain name of AWS. So the only requirement is that it should be publicly accessible. That is only prerequisite. So if that is only prerequisite, and based on the rule that you configured in the traffic manager, it will route the traffic to that guy. Uh, so it is just a uh, it is just routing the traffic. There's nothing else there. Nothing else there. So the traffic routing could be either inside Azure or outside Azure. So um, only
Okay,
prerequisite is that the domain name should be publicly accessible. That is only prerequisite,
okay,
and it will monitor the health checks, and it will also apply the traffic routing rules on top, so that intelligence is added there. Uh, that's all. Uh, I mean,
okay.
I'm not sure whether I answered your question. So, was it? Did, maybe I'm missing something.
Uh, no, it's not that. What I'm trying to understand is Azure versus non-Azure.
Uh-huh.
Same with the comparing this with the traffic manager with the Route 53. What is this difference capability? But even if there is a difference, why would one worry about routing a traffic to non-Azure platform if it comes to Azure with the IP of that?
Yeah. No,
So
no. See, I mean, generally, uh, I mean, your question is when Azure. you're using Traffic Manager, why we should use AWS, or why need to worry about AWS, or something,
Yeah,
someone else.
yes,
Okay.
yeah,
Yeah, that is. I mean, most of your applications in the enterprise nowadays, they're following multi-cloud strategy, right? So just to avoid a vendor lock-in. So basically, some of their let's say on day one when they started, so they selected AWS, and they already deployed their applications on AWS. Let's say a couple of years later, they want to have multi-cloud strategy and want to move also use Azure, and their newer application that they're building after 2 years. Let's say that is in Azure. Uh, Now there's a requirement coming where like they want to have some the traffic should go to the AWS component, also to Azure component, and so we need something outside this to route the traffic. So
hmm
in that case, they will select, and also they have on-premise to add to more to this confusion. They also have an on-premise application running also in their on-premise data center. That was exposed on a public endpoint. So now they need to connect all these three. So and they should also apply this intelligent routing on top. So then Traffic Manager is a solution. I mean, this is not very common, but only for our enterprise which have multi-cloud strategy, then this will be a requirement.
okay,
Yeah.
okay, yeah,
So
okay,
they already embraced AWS, and let's say they now want to use multi-cloud strategy, and they want to use
yeah,
Azure, and now there's a requirement to use both for a common requirement. So
right, okay,
then the situation will come.
okay,
Yeah.
okay, sure, thank
Yeah.
you.
I mean, now it's very common. I mean, now generally the market. I'm talking about generally the 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 enterprise companies are embracing multi-cloud. They don't want to have their the logged in with just one cloud vendor. So
Yeah, it is possible. They will try to use the
yeah, best out of both.
best of
Let's
both.
say they are using SQL Server and Windows Server, so they prefer Azure because Azure will be cheaper.
Yeah,
But
yeah,
let's say
correct.
they want to use some machine learning based implementation, and they will use AWS for that. So the traffic should be
Yeah,
routed to both.
right.
So yeah, then you have this requirement.
Okay.
Okay. So yeah. So with this, uh, so you, so this intelligence is is the what for which you are paying. There's nothing else. It is just routing the traffic, nothing else. But that intelligence applied on top is where the specialty of this product is. The intelligence is given to you. The Whereas the end user you need to provide this what should be the rule that should be applied, um, like when the traffic has to be routed, what rule should be applied. So that is what you need to provide as input to this traffic manager. So there are a lot of options here. As we discussed the last session, there are at least 6 options here. One is by priority. Uh, so here, if you see from the name itself, we can say it is you can give a priority. Let's say you have 3 VMs. Let's take about this scenario. So primary priority one, failover A, failover B. These are three uh, duplicate copies of the same web application. Let's say. So you have one. Yeah, each of them are hosted in different regions. Um, but any given time, traffic manager has to select one out of these three. So in that case, you can give, if you're using priority as your routing method, uh, then by default you need to tell which is highest priority. This numbers matters, like priority number 1, 2, 3. So one is primary. Of course, two will be a failover A, and three will be failover B. So when primary is applied as your priority, when a traffic comes to this traffic manager, so it will check this priority item. So whichever is the lowest priority, so that will be given a first preference. But let's say if the primary one is down for some reason, so then we'll go to second priority one, which is failure A. So in this process now, the client will be routed directly to failure A. Let's see here. So that is a priority option in this. And let's say this is very basic. It do not have any intelligence here, but uh, uh, so but you have other options. For example, let's say you're interested to route the traffic based on the weightage. Um, so by default, you will give a weightage. Uh, let's say 50 is your region A's weightage, or the region A, test A, and region B. These are the three instances that we have. Now, first region A, your weightage is 50, and for other region, your weightage is 5, and for this region, weightage is 50. Now, let's say if the primary is down, then it will look for which is having the next higher weightage. So not by priority, it will goes by the weightage number. So obviously this is having higher weightage, so the traffic will be routed to this one, not this one, for example. So that is the weightage based routing method. So this is the intelligence that your the traffic manager is giving. So basically, when it has to make a choice to traffic manager has to make a choice to select one between these three, will apply these rules and then pass the IP address of let's say in this case it is B. To pass the IP address of this region B's stuff to browser, so that way now browser will directly contact this guy, not for example others. Right. So that is the weightage aspect. Other option is performance. It can also look at performance. So here the performance is primarily it is looking at the closest endpoint. So that is what it looks at, the closest endpoint in terms of the lowest network latency. So this is very commonly used. Performance is like commonly used routing method. So let's say your traffic is you have your West US, North Europe, and East Asia. So these are the three different regions where your same instance is deployed. Now traffic manager has to make a choice between one of three. Let's say for configuring this as performance, it will primarily look at given your traffic is coming from which location. So it will look at what is the latency parameter. So for West US it is 15 milliseconds. For North Europe it is 75 milliseconds, and East Asia is about 50 milliseconds. And now let's say obviously West US if it is active, the traffic will be routed to that. But let's say if the West US location is down, then the traffic will be routed between these two. So, but 75 milliseconds is a better lowest latency, so it will route to that, not the Asia one, for example. So that is this performance aspect. And the next one is geography. So the geography aspect, it will look at the geography from where this user is this user's traffic is coming from. So it will look at the geographical location from probably from the DNS. It will get that information basically from the browser, and it will apply the geography rule in this process. Let's say the traffic is coming from let's say France, Paris, or anywhere in Europe, let's say. So then the traffic will be the choices that you have where your instances are deployed are in one in Germany. The second one, it's also possible to have a nested profile in Traffic Manager. Like it can the traffic, let's say Mexico versus Asia. So Mexico will go to this, and Asia will go to this, uh, and the rest of the world is endpoint two. So now let's say traffic is coming from France, then France is closer to Germany compared to Asia, rest of the world. So then the traffic will be routed here. Uh, or the traffic is coming from directly from Germany, so the traffic will be routed here. So yeah, so it will apply the geography location from where this traffic is coming from, and then traffic manager will pick that uh, based on this routing method, right? So and then next one is multi-value. This multi-value is let's say you have multiple. It will return uh, all the healthy endpoints. Uh, And now the client has to make a choice. That is why it is multi-value. So it will not return one. In all these cases, it is returning one by applying these rules. In all these things, it is applying only one. It's returning only one IP address, is the rule that's satisfied. But in a multi-value case, it will return many. That is the only difference. So the many will be based on the health parameters. Which endpoint, let's say both these endpoints are healthy, so it will send IP addresses of both these endpoints. And now the client has to make a decision where to route the traffic. So it is this is not very common requirement, but there will be cases for such cases where I'm interested to send my traffic to all the only healthy endpoints only, and I you return me all the healthy endpoints, but the client I will make a choice. So if that is your requirement, then multi-value is your option. So and then the next one is the subnet. So the subnet is basically it will return all the IP addresses within of all the basically all the IP addresses to a specific endpoint. So within the traffic manager profile. So for example, when a traffic is coming from this IP, uh, then it will primarily check whether this IP is configured to which location, and it will if this IP is closer to the end user IP, which is located in North America, so it will route the traffic to Northern Europe. It will route the traffic to Northern Europe. For let's say if this IP from a different user is coming from which is not registered, so then it will route the traffic to the rest. Basically, in this traffic manager, I'm telling what are all the from the subnet from this. You can say it is we're talking about the the IP addresses. So we can tell, let's say this IP address A to Z. You should route the traffic to this. Anything not in this A to Z set, route it to different. So that kind of a rule that you can configure. Basically, you're sticking to IP addresses, the traffic based on the range of IP addresses. So then the subnet will make preference. Um, Basically, most of the cases you will know the client. Let's say if it is a standard traffic, it is not exposed to public. Only limited set of users only will hit. Let's say you are expecting traffic only from 10 IPs only. Then then you can define a rule, and those 10 IPs are internal IPs, and you want to expose more detailed information. Then in that case, you can use the subnet as your option and tell what these 10 IPs are. So the traffic when coming is from those 10 IPs, it will route to that. For rest of the IPs, it will route to the different instances. So basically, it is sticking on the IP address as a means to route the traffic. So that is this subnet based routing method. Yeah, I think that's all I guess. Yeah, yeah. So summary is this traffic manager is having various options to select where, and it is sitting outside your network, and it will make a decision where which instance to route the traffic to. It can apply rules like priority, weightage, performance, based on the latency actually, lowest latency, and geography based on the geography from where the traffic is coming from, and this multi-value is like more than one IP addresses. It can return more than one healthy endpoints, and now client has to make a choice. So that is multi-value, and subnet is based on end user's IP address range. So, so you can give a bunch of IP address ranges and then route the traffic to that endpoint. Right? So that is all about this traffic manager options. Now, in addition to the traffic manager, also has additional features like it can do endpoint monitoring. It can closely monitor, as part of the health probes again here. It can also monitor the endpoints very closely and get the health of those endpoints. So basically, um, it has also additional tabs in the traffic manager where you can go and check what is the health of this endpoints, and also it can look at their integrated. As it can also this endpoint can be it's global to all, like out inside and outside of IP address of Azure, and it can also integrate with a lot of Azure specific endpoints also. So when I say Azure endpoints, we're talking about all the IP addresses of a VM will have ending with azure.com. So all those Azure integrated endpoints also it can monitor, and it can also monitor the nested endpoints. Uh, so one endpoint is calling another endpoint is calling another. So if you have such nested endpoints, you can monitor all the health of all the nested endpoints also. And also it can show the traffic view geographically. So I mean, it can show how, I mean, let's say if there is a requirement, an audit requirement, why this traffic is routed to this server, then we should have a clear log, right? So you can see the traffic view from where this from which client this hit has come and uh, what is the traffic view in that case. Like you can see it in geographical, you can see it graphically how the traffic flow is happening. Um, and also the real user measurements, and also it has a lot of metrics and alerts that you can make use also. So these are the features of this traffic manager. Right? Yeah. So maybe here I'll try to cover the theory part of this application gateway, and probably in the next session I will give a demo for all these two together. Uh, so maybe I will cover this section, but maybe I can quickly show you this traffic manager option where this the problems with this load balancers are I realized that this takes a lot of time to create this load balancers. Not just this, even I was trying the other options also. Um, Especially, I had to wait for this backend pool and health probe. And literally, I was waiting for almost 20 minutes to get this health probe registered. So probably that is uh, not a good option for a demo where it takes a lot of time to keep on waiting for it. So, but I think it is maybe because of network issue on my end also. But at least I saw two times it is like behaving like this. So probably it takes some time to register your health endpoint, and so that is one reason. Probably I think maybe I'll try to set up this before so it will save some time. Uh, but anyway, I will create quickly here. I'll show you the traffic manager options here. So traffic manager profiles. Okay, so here this is where I was talking about these options that we saw here. So here the performance, weighted, priority, geographic, multi-value, and subnet. So based on what you select, and it will accordingly route the traffic. So if you look at this having, it will have an internal domain name that will be generated for you, so that it can apply the traffic to that route accordingly. Um, Maybe I said like I will, uh, yeah. So I think that is the one. Right. And here traffic manager profile, and then you will once you create traffic manager profile, you will associate this traffic manager profile. I'll quickly show you. So I'm selecting performance and resource group. Let's let's probably take the existing one. Create. So I'll take this. Okay. So yeah, so once um, uh, maybe I'll show you the options inside. Maybe in the next session, I thought it is good idea to show like how I showed today, where I will create the setup for you beforehand, so that you will know what is how does all these patterns work, so rather than showing it live on the demo. Okay, so this is I just created sample traffic manager profile here. So if you see here, this is where this configuration comes, where you selected. Of course, you can select that, but you can change anytime these values to apply what should be the priority, the routing method that should be applied, and of course, it will look at the HTTP port and profile and other things. And the real user measurements. This is what I was telling about. Like you can generate the traffic. Basically, it will generate a key, and you can embed the provided code in the web property to send the network latency measurement. So, as this is all coming under the network category, so there is always debugging is will be a bit tricky, especially when someone says this traffic manager is not working as expected, or someone says that. So then it's always important to collect the metrics about the health of this traffic manager profile. So that's where this measurements will help you to identify the health. So basically here you can generate key and you can monitor the traffic on this website. Let's say you can embed this JavaScript component anywhere, so that you can use it for your monitoring purposes. Again, so we'll come to the monitoring category. Then this is what I was talking about, the traffic view. So it will help you to give the location, volume, and latency information. So again, coming under the monitoring category. So where you can this comes with an additional price. So I'm not using it here, but it's not free. So but it will probably help you to give the live location of where the traffic is coming from and what is the volume of traffic that is coming from, and also the latency it took to reach from the client IP to the final destination. So what is that latency it took? So all this information you can see it by enabling this traffic view. Of course, the endpoints is this is where you will configure your endpoints. You will create an endpoint here with some name, and this is where you will tell what are these endpoints that you're looking for. For example, all these endpoints that we're talking about. So all these are various endpoints. So mostly these endpoints are we're talking about a web application here, right? So the end traffic is routed to a web application here. So it is exposed on some endpoint or some IP endpoint. So in Azure, the category where a web application will be used are primarily these are the four options: a cloud service, which is a legacy a web application, is what is cloud services. Yeah, so it is classic model, but now the new one is all app service. So app service is like you're hosting a web application. So equivalent to that is app service. So basically it's nothing but it will take this app service component is like deploying your Java component or a .NET component, which is a web application running on some port. Uh, you can deploy that in Java world it is a jar file or a war file, and in the .NET world it is the libraries, the exe. So you'll deploy that onto an app service, and it will be by default app service will give you a URL where you can see this web service. So so yeah, so that is what this app service. So basically, it's a web component, or it could be your public IP. Let's say you deployed your like how we saw the IAS server that which you deployed on a VM, so which is having a public IP. So that could be even that. So these are the app service. I mean, you ignore cloud service because it's almost legacy. But the new world, it will be mostly app services is what you use for exposing a web application. So basically, behind the scenes, all these diagrams, all the diagrams that you saw here, uh, this is a symbol of a web service. Sorry, app service. So app service diagram is this. So all this box is an app services. It's nothing but a microservice application deployed, or it could be a simple web application deployed. So running on some port. So it could be a simple hello world application, or it could be some simple IAS based application, or it could be a simple, it could be even a complex web application, or it could be a microservices based application. Something which is exposed on an IPN port. So, so that is what this component that you see here. Okay, so let's select this, and then you will select your target source, and then add, if you have any custom header requirements, you can configure the headers for especially this is applicable for the HTTP traffic. You can override the custom headers in the profile. So the advantage of this is that whenever some traffic is coming from a client, it can look at the header. The browser will have the header information. So it can look at the header information of a browser, and it can route the traffic based on that also. If you want to say that any traffic using this header, if you have a requirement like that, then you can add that requirement here. Right? So that's all. So once you add this, then obviously your traffic will be routed to those endpoints. So this is where you will configure, you will do multiple ads, and you will register all your endpoints like this. All your endpoints like this, you will register it. Click add your first endpoint, click add your second endpoint. Likewise, you define all your three endpoints here, and that's also traffic manager will know, and also to look at the health parameters, and then it will probe those, and then it will look at the health parameters, and then it will make based on the traffic rule that you configured also here in this configuration. Based on traffic, it will apply this rule, and also it will apply the health parameters. It will look at these two routing method and probe. So health probe. These are two things that will be considered, and the components that it needs to apply traffic are all configured in the endpoints. So, so summary is the traffic manager requires three things. One is what is your routing method, and of course your probe health parameter, like which port it has to listen for health, getting the health parameters, which is second one. And then third one is what are the endpoints that need to monitor. So these are three items that traffic manager should know, and then it will start routing the traffic by this route. Okay, and maybe as I said, like I will give a demo for this in the next session, so it will save some time of creating all these things from scratch. The next one is let's move to the next component. So any questions here before we move to the next one?
No, sure. We can proceed. Next one.
Sorry.
No, we don't have questions.
Okay.
Yeah. Okay. Thank you.
Yeah. So that's about the traffic manager. So next one is application gateway. Again, going back to that table where we saw that. So now we're talking about application gateway, which is now we're talking about HTTP and HTTPS based traffic. So these are load balancer, and then we just now saw the traffic manager with a component sitting outside. So these two are related because both are non-HTTPS traffic, just that it is regional and global. That is the difference. But now we're talking about I mean non-HTTPS. So which you're talking about here, it is in OSA model we're talking about the layer 4, which is a networking based traffic. So, but if your application is pure web, then and you are looking at pure HTTP based traffic, then again we have two options. This one, which is regional, and this one, which front door, which is global. So, so now let's talk about HTTP or HTTPS category, which is at regional level, which is application gateway. So this application gateway, this application gateway, this component is pure a web traffic load balancer, uh, and this one comes under the low OSI layer 7 category. So we are talking about pure application based. I mean OSI 4 level 4. The previous ones are all network based traffic, and levels OSI layer 7 is application. Application is like you're talking about the pure application that is deployed. Even if you look at the data also, uh, which is being transferred over the network. So look at the application load layer 7 load balancer, and this supports both HTTP and HTTPS. Uh, one unique advantage in this is that it will help URL based routing and also the multi-site routing. So this URL based routing is a unique feature, so where it can route the traffic based on various URLs. For example, let's take images and videos. Okay, so when an end user is hitting, say, contoso.com, so it is coming to an application gateway. Um, so this application gateway, based on the URL that is being hit, uh, if a user is using slash images in the URL, then it will be routed to this image server pool, the VMs under the image server pool. And let's say if it is video, then it will be routed to the video server pool. So based on the URI, so the URL subcomponent is URI. So based on the URI, it can route the traffic accordingly. So that is a unique advantage that is there in application gateway. Um, and this is also, from this itself we can see that it is a multi-site also. I mean, this image server could be um, in a different location. This could be different locations in different place. So it is like this now routing um, traffic to multi-site here. Um, I mean, this is pure URL based routing, but also it can route to a multi-site also. So that is also possible. And and also other point that you need to note here is it also has WAF. WAF is a web application firewall. Okay. Now, um, one drawback in HTTP or web applications is that it is prone to to injection attacks. So always HTTP traffics are prone to injection attacks because it's on public internet, right? So anyone can try to hack, and try to um, produce malwares and other things. So so it requires an additional security layer to be developed on top, which to handle the security aspects. So that's where this web application firewall component is deployed. But this is an optional component for you. It's up to you to enable this or disable it. So, but it's always good to enable it. But this is a separate component in Azure altogether. So, but it works together with the application gateway. Uh, but as such, WAF is a separate component also. But it generally goes in line with application gateway. But it's an optional component. The purpose of this WAF is primarily it addresses the common attack vectors like SQL injection and cross-site scripting. So, I mean, it's not. I just gave this two, but there are many under this category. But these two are more common attacking vectors in this space. Um, Apart from that, I think we just discussed about certificates, right? The SSL or TLS. So it has. So this will support certificate based authentication also. So So it is centralized SSL offload and SSL policy management. So you can distribute the certificate. If your organization is having a certificate, it can deploy a certificate, and it can do the encryption and decryption for you. Again, that's what is covered in the next statement: centralized SSL certificate management for encryption and decryption. So, I mean, the advantage here is that this application gateway is taking care of encryption and decryption. So that way, you don't need to worry about handling this encryption decryption inside your application. Let's say in a older in the days before this application gateways are there. So generally there'll be a web server here. I'm talking about 5 years before. The solution architectures will be were being like here. Generally there'll be a web server. Um, uh, so any traffic that is coming, it will first come to the web server. Web server will blindly route the traffic. That's all to the app servers. Um, so it doesn't do any SSL stuff and all RTLS. I'm talking about few years back, where in that case you have to handle that apart inside your code base, inside running inside these app servers. So, but now that headache is now taken care by the front runner here, the application gateway. So that way you don't need to worry about handling that part inside your code base. So that makes your code bit lighter. Um, and also it supports cookie based session affinity. Again, this is similar to what we discussed before, where where if you want to route the traffic to the same VM again and again, then you can use you can apply the session affinity so that the successive calls will always go to the same VM, not to the different VM. So it supports that. It's a very not very common requirement, but yeah, it is just if you want to route when the performance is your goal, but your application is not it doesn't matter if it is using the session affinity concept, then it is okay to apply this rule. Um, and also it supports public, private, and hybrid websites as well. So all this on the other side. So when it supports multi-site, the site could be a private, public, or hybrid websites. And also important thing is it supports auto scaling. So let's say you are expecting more traffic, uh, let's say on a Black Friday day or something like that. So you can also increase your capacity for this application gateway so that it can handle more requests from end users. Um, and then once the demand is back to normal, it can scale down, like scale down of application gateway is possible for the front. Based on traffic load patterns, you can apply auto scaling rules on this as well. So that's about this application gateway. Uh, and if you look at how this works, is basically um, as and when a client sends a request to application gateway, um, first it will uh, generally it's all we're not talking about the DNS like Azure DNS is something where it should be returned back to the client, which is two. I mean, end user is hitting the IP address, so which means sorry, it is hitting the domain name. So we should whatever be it is the load balancer, it should send the IP address of the domain back to the browser. So that is and in this process it will apply all these rules and decide which IP I need to send, whether it is uh, any one in this backend pool. So it will apply all the rules and then it will pick one IP out of these many, and it will give the IP address back to the user, a browser, and browser will directly contact that resource. So yeah, so it's a similar concept like how this works. But only difference is that here in application gateway we have something called listeners. Uh, so once the traffic comes back from application gateway, uh, this application gateway will first go to a listener which is deployed as part of the application firewall. So it will look at it will apply the listeners. The listener is primarily checks for the connection request. Again, front-end IP address, protocol, and port number. So it will apply the rule what we saw before, when even load balancer, it will the algorithm, whatever. So listener will apply this algorithm on this via listener, and also it will look at if there are any rules available. You can also configure a lot of rules here. It will check for the rules, and it will based on, let's say, you can apply a lot of rules like if a traffic is coming from a client from with this header, route the traffic to this virtual machine. So you can write a lot of rules like this. Let's say if traffic is coming from the same rules whatever we saw before, right? If the traffic is coming from this IP, then route the traffic to this virtual machine. If the traffic is coming from internal on-premise IPs, then route the traffic to this internal on-premise server, app server. You can write all these rules like this, like if then conditions, nothing but. So it will apply all these rules on the traffic and then route the traffic to the respective components deployed in the backend pool. So, and in addition to that, if you also enable WAF, it will also check it will check if there are any security threats applied. It will check for security threat, and if only if the traffic is free from security vulnerability, then it will route the traffic to the backend pool. Otherwise, it will straight away block the traffic. It will not allow the traffic to go to the backend pool. It will block the traffic. So so basically it is a combination of a listener and rules configured, uh, and also it applies a WAF security threat aspects also, and then applying all these things, it will route the traffic to your backend pool. So the backend pool could be a VM, or it could be a VMSS, like pool of VMs, or it could be an on-premise setup, like an application running on-premise, or it could be an external app, not even on-premise, it's another third-party external app, or it could be an app service, in a web component inside an Azure. It's pure Azure component. So basically, we are not talking about infrastructure as a service, um, or it could be an on-premise service, or it could be a PaaS service. So this is a PaaS service for deploying a web application. So it supports all these features. So yeah, so that's how this works. And other input is this, as you saw, this listener, right? So this listener uh, is having combinations, like it can, you have choices to make in listener while you're giving applying this rule. So basically, you can use options like basic. You can use basic listener or multi-site listener. So basic listener is something which listens to a single domain site. But let's say if your requirement is to look for multi-domains, so then you should use multi-domain, multi-site listener. So the listener component is like, it will again, it does the same thing behind the scenes. It will apply the probe, health probe on that component. So it will apply the health probe. So in that case, we should tell whether this is a single site or a multi-site. So accordingly, you should choose a listener component in that. So it's basic or a multi-site. And also these routing rules that we refer here. These routing rules also they are used to route the traffic from listener to the backend pool. Again, also here we have basic and path based. Basic is like all requests. It's a very simple rule where all requests are routed to the backend pool directly. But if let's say you want to apply this path-based routing, what we saw here, images to this pool and videos to this pool. So you have a URI-based routing or a path. It's also called as URI-based routing or path-based routing. Both are same. So, we have requirement like that. So then we should use path-based routing. Of course, the health probes also are equally important. In all the load balancers, the four load balancers, this health probe is something common. So it will monitor the health based on the port, the IP address that you provide. It will monitor the health. So yeah, so that's about this component. Um, yeah, so additional important features that we need to know then is very commonly used because it supports HTTP, HTTP and HTTPS traffic. So some component that we need to know here are SSL or TLS based termination. So here generally when you talk about HTTPS, then this TLS will play a role where generally the request to the application gate is primarily for a security aspect and also encryption decryption. These are two things that TLS will take care. I mean TLS and SSL are same, and SSL is the older name, but TLS is a newer name. And but people SSL is more popular. That's why people say SSL. But SSL and TLS are both the same. And one thing is that TLS. I mean, you can forget that name SSL going forward. But TLS is the new name. So TLS is like transport layer security. Here we should tie back TLS to versions. So TLS 1.0, 1.1, 1.2, and 1.3. So 1.3 I think is the latest right now. TLS is a specification, like how the security HTTPS traffic should travel. So TLS 1.3 is the latest specification, and Azure supports TLS 1.3 for all the traffic. But 1.0 is I was referring a podcast today morning, and I heard that very, I mean, like even though Azure is now supporting TLS 1.3, but there are still old VMs or other on-premise VMs, which is like Windows 7 and Windows 8, still in use. They still use TLS 1.0, and any traffic that is coming from very old VM to an Azure VM, even though it is 1.3 and above, 1.2 and above, um, still the security vulnerabilities are found. So, so, so now Microsoft is making uh, um, a, a wider. It gave a release saying that ensure that if you're using a Windows 7 or any older VMs, ensure that you handle your application. Like your application should be which is deployed on the machine. It could be .NET or a Java component or a Python, so whatever it is. So it should be TLS 1.2 above. So it's like 1.2 or 1.3. So it should support that, so that your traffic is more secure. So um, yeah. So and also because of this COVID situation, a lot of security issues are coming just because everyone is working from home and not in like not in office, and so this all these servers are sitting in office mostly, so or in data center. So they want to ensure that um, everyone is using TLS 1.2 and above just to be on safer side, so the traffic is more secure. Yeah. So yeah, so that is why this is for HTTPS, this TLS is a very important concept. So requests to application gateway can be secured by using TLS, and also the request to the backend resources um, uh, it can go unencrypted, um, just because I mean it generally lifts the burden on the backend pool for decrypting the request. So basically, what it says is again here you don't need to take care of encrypting or decrypting your application because that is burden that is taken out from you and it is applied at here rather than doing it inside your application. So this is the TLS authentication stuff is taken care here. So it is all from here. It's all Azure boundary, right? So it is not open to public. Or network traffic is within the backbone of Azure. Uh, so from here you don't need to bother about this traffic which is already coming inside gateway. So it could be it could still go unencrypted. So it is secured because it's all on private network, not on public internet. So um, so that is the advantage that you get by using this. And the other one is the session affinity. So I think we just discussed this. Allow a user session to redirect to the same server again and again for processing. Uh, if, again, if the state of the user session is stored on the server, then this is something a very useful feature for you. So it is based on the user session that is stored on the server, so that the successive traffic is always going to the same server rather than a different server. So that way it is faster. Um, you can load the page faster. Right. So the session affinity. These are the very common uh, feature which are used in this. Most popular features out of this application gateway. I mean, just to remember, so this is application gateway is primarily for URI or URL based traffic and multi-site and WAF and TLS and session affinity, auto scaling, and it applies HTTPS rules and it can support multi backend tools. And it has this listener is having basic multi-site and routing rules. If you see here, it is path-based and basic and path-based help probes. Then SSL TLS support, then session affinity support. So these are all the features which are mostly used. It is just a summary of all the features because I see a lot of questions coming in this in the exam. So I mean, I'm talking about the architect exam, just preparing. So I had to some from exam point of view this all these features are important to know. I think more or less we covered this SSL termination is primarily for help you to take care of this end-to-end encryption. Um, then auto scaling also we just discussed, scale up or scale down based on the patterns. Um, then zone redundancy. This supports zone redundancy, which means the VMs could span across multiple availability zones. So it supports zone redundancy feature by supporting the multi-AZ option. Right? And this static VIP. So this which means like it uh, similar to what we saw. The public IP is something which should be fixed and should not change over time. Otherwise, it will create. I mean, because that is what you are exposing to public, right? So people should know the IP address of public IP of this. But if you change it, then like users will be getting confused. So it's always good practice to not to change the public IP of this application gateway. Right? And then so static VIP is you should when you're applying public IP, generally you have two options, right? Dynamic IP and static IP. So when you're creating a public IP, you should always use a static IP, not the dynamic. Dynamic is like it can change when you restart it. So, but IP should not change because otherwise the end users will be confused. So, and it supports WAF, Web Application Firewall. We also saw this. But it takes care of protection from various attacks like CSS, cross-site scripting, and SQL injection attacks. And ingress controller for Kubernetes services. So, I mean, when we talk about Kubernetes, we'll discuss about this. But Kubernetes also would need an application gateway kind of a requirement where all the traffic will come to one place and from there the traffic spans across. So this ingress controller is a feature which supports in Kubernetes. We need to have this ingress controller which works similar to application gateway. So ingress controller, from the name itself, ingress, right? In traffic in. So and it controls the traffic. So that's why it's an ingress controller. That's the technology of Kubernetes. But yeah, this ingress controller can be integrated with application gateway. So you can use application gateway along with Kubernetes. That is what it means. So runs within AKS cluster and the traffic balanced traffic between Kubernetes pods. So it can do the basically it says that it can integrate application gateway can integrate with AKS also. So right, and then URL based routing. So we discussed slash video versus slash images. So it can route the traffic accordingly based on the path. And we also discussed multi-site hosting. So we can configure the routing to multiple websites, contoso.com or fabricum.com. So you can configure both sites and traffic will be routed for both sites based on some rule that you configure. If the traffic is coming from this location, route it to contoso.com. If the traffic is coming from this IP, you can route to fabricum.com. So like this, you can configure rules to redirect the traffic. And redirection, HTTP to redirection is a very common feature in a typical um, gateway kind of a like the load balancer. So basically, the traffic HTTP to HTTPS redirection um, and also path-based redirection and external site redirection. So you can redirect um, uh, the request will come from one site or one IP. You can redirect that IP to a different in the background. So this is very common requirement where you have let's say you changed your domain name. Let's say you're using domain A and now you change it to domain B. Uh, but uh, but you don't want to expose that new domain to end user. Um, then in that case you can use the redirection logic. So because you change your domain name, but the domain or the old domain is more popular and it is already used by many people, but you don't want to change that. But internally you route the traffic. So yeah, so that traffic redirection can be done using the application gateway. And also it uses a path-based. Here also it can apply this path-based redirection. If the old site.com/video, it will redirect to new site.com/video. So it can do that redirection based on the path. Um, and also the external site redirection. And it's this session affinity that we discussed. Keep the user session on the same server. Then yeah, this is something very unique feature. It also now supports. This is a recent addition. Application gateway now can support even WebSocket traffic and HTTP2 traffic. HTTP is what we know, which is HTTP is 1.1 is what we are mostly we're all using. But the HTTP version 2 has come now, which is like between 1 and 2, it is like after a long gap, it has come. For example, almost till 15 years, we're all using 1.1 only. But now HTTP, after 15 years, HTTP2 specification has come, and most of the browsers are supporting HTTP2 now. So as per HTTP2, and also all the future developments all will happen on HTTP2 traffic only. Because one will be deprecated very soon. But still, most of the sites in the world is all HTTP1, HTTP1, 1.1. So this two traffic, the advantage is it is a full duplex communication between client and server. So which means uh, both client can send information to server and server can send information back to client, but within a same channel. For example, if you're doing a get API, uh, 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 so generally it's all one way in 1.1. So client can send a request on a get API to server, and server can send the response of that API. So and then the connection is closed. Again, if your client wants to make another call, he has to again hit the get API to get the response. Um, but here in HTTP2 traffic, you don't need to terminate the connection. You can still, client can make multiple calls to the server without connection disconnecting, without disconnecting the connection. So that is what is the full UPEX communication means. So especially if you look at all your um, the Ola, Uber, ride, the ride app sharing, right? So you can, for example, all the you can you can see in a map the vehicle is moving live, right? So without page being refreshed. So they all use HTTP2 traffic behind the scenes, where it uses either a WebSocket based communication or a GraphQL based communication, where that the page is not refreshed every time. So if you are not seeing the olden days is like if you want to get a latest geolocation, you have to refresh the page. Um, but in HTTP2 or WebSocket based communication, refresh is not required. Connection is open. Client can hit the server multiple times, or the server can send the response back multiple clients. Like, oh, you need to disconnect the connection. Um, so that is this WebSocket or HTTP. So basically, the point is the application get supports that. That is the point. Um, and the next one is the connection draining. I think we're running out of time, but I think let's logically close here. The connection draining. I think this is primarily graceful removal of backend instances and don't receive any new requests. For example, connection draining feature is, for example, out of the three VMs that are connected the backend pool. Um, let's say one VM health is bad and it is going to shut down or it is not healthy. Uh, but let's say there's a connection already established uh, with that. So, but then this application gateway, uh, the application gateway, let's say, is pushing data to this virtual machine, uh, and this and let's say, but this virtual machine is health is bad. From the health probe, it can identify this virtual machine health is bad. So, but there is already a connection established for one client from one user. This is getting served. So what it will do is application gateway will not immediately terminate. It will wait for that connection to give a response back uh, till some time. Like you can give a buffer time, let's say 30 seconds. It will if the connection is already active on that virtual machine. It will not terminate the future traffics. It will definitely terminate the future traffic, but ongoing connection to serve the response back, it will wait for some time before it terminates from the pool. So, so that is what this connection draining is. Like it will wait for already existing connection to log gracefully shut down. Uh, so gracefully complete rather than force terminate. So, so that is the meaning of connection draining. Uh, so graceful removal of the backend instances and of course it will not receive any future new request will not come to that server anymore, but it will try to wait for the existing connection to gracefully terminate. Um, next is the custom error pages. Right, it can, let's say, if you're getting an error, so it generally will show a custom error page, right? So, I mean, default error page will be there for any error that happens. It will route to an error page. But let's say you want to have a fancy custom error page for you just to show with the branding images and all. So then you can create a custom error page and any HTTPS HTTPS 400 or 40x or 50x error codes like so server based errors. So if any errors happen, it will by default take you to this error page saying that sorry for the inconvenience, there's some issue behind the scenes, something like that. So you can show a custom error page rather than showing the default error page. So it can handle that. And also this one is the rewrite of HTTP headers and URLs. So rewrite from the name itself, we can say that let's say you want to remove some sensitive information from the response headers. or you want to enrich the headers, or you want to strip the port because connection is coming from one port and you want to strip the port for security reasons before reaching to the backend pool. So basically, you are adding more information from the client, which is enriching the header, and so you are removing any sensitive information coming from the header. It can do all that cleanup stuff before the traffic is passed to the backend pool. So it can enrich, or it can shut down, or it can remove, or it can strip. So it can enrich and strip. It can do both, or remove. Um, then sizing. So it has options like it can support multiple sizes, small, medium, and large. Like application gateway based on the traffic pattern. We can start with simple, small, maybe later it can move to medium and then to large. So it offers sizes for you. Yeah. So that's about this application gateway.
Shyam, can I ask a question?
Yeah, sure.
Yeah. So this application gateway, is it very equivalent to the application load balancer in AWS?
Yes, it is. It
Oh,
is.
okay.
Yeah,
Okay.
yeah. So there it is. Uh, I mean, in AWS load balancer uh, is two components inside a load balancer in AWS. But here they're separated. In AWS, the load balancer it's just called as load balancer. So AWS load balancer. Uh, Inside AWS load balancer, you have components like network load balancer
NLB, yeah.
and you have application load balancer. So broader, it is just load balancer. Uh, so here we are splitting it into two. Now coming to Azure.
I
Um,
see.
so this A is application load the Azure load balancer, which we saw in the first slide. The B, which this application load balancer is application Azure application gateway.
Okay.
So in AWS world, it is just one name, one product, but it has a
Two
sub-product kind
components.
of a thing, like network and application. Basically, this application one will support HTTP traffic, HTTP, HTTPS. That is what the features that we just now saw. So it's equivalent to application gateway. Uh, so yeah, but this is load balancer. It says, but primarily we're talking about network here. Network load balancer. This is web traffic. Yeah,
Thank you.
got it.
Yeah. Thank you.
Yeah, right. Yeah, I
Right.
think in a, in a,
Much to know. Very nice.
sorry,
Very nice.
sorry, I missed your point. Sorry. What's the
I
point?
said too many to remember. I said too many to remember. Yeah.
Yeah, correct. I think there are many things to remember here. Yeah, I think as an architect, yeah, it is good to know that these features, these products are available, because I mean,
Right.
too many choices will create confusion, but at the same time, you have a lot of you can pick based on a requirement. So, but
Mhm.
yeah, I think the features, I mean, it looks load balancer, but there are a lot of things behind the scenes that load balancer does, based on the scope where it is and based on what traffic are you talking about, and what features are we talking about. So based on that, you have choices to make. So as an architect, we need to know these products because all these four come under the same load balancer. It balances the load, but
Right.
the scope matters, where it is located matters, what traffic it accepts matters. Based on that, we have choices to make. So that is what as an architect we need to know. Yeah, I think that's where this knowing in detail about this will help because yeah, every at a high level all are load balancers, but if you go inside, each has its own unique features. So yeah, so that's good to know that.
Yeah.
Okay,
Thanks, Sam,
yeah,
for the deep dive. Thank
yeah,
you. Thank you so much.
thank you. I think in the following session, I think we'll go through the demo of these like how we saw for load balancers.
Thank you, Shyam. Thank you
Yeah.
so much. See you
Yeah.
next week.
Thanks, Shyam.
Bye.
Thank you very much.
Bye bye.
Yeah. Good night. Thanks.